Okay, we're going to look at this question here. It's about a maximum minimum question, optimization question, they say sometimes. This is a cylinder. It's got a radius of r, so from the center of the cylinder, it's got a height, we don't know, of h, but the distance from the top, from the center to the outside here, that's a right angled triangle because height is perpendicular. That hypotenuse in the picture is 6 centimeters. Well, the first question is determine the radius r of the cylinder in terms of h. So r equals, or r squared equals. Well, let's just try that. Well, you look at that right angled triangle that's perpendicular and you should be thinking, well, it's either trigonometry or it's the Pythagorean theorem. Well, r squared plus h squared equals 6 squared by Pythagoras. And that's your first idea. Hey, if we subtract h squared from both sides, if we subtract h squared from both sides, we will get the right answer, which is, and I just want to fix it up a little bit here. I want to fix it up a little bit here because for some reason, I've reversed this here, and that's a little bit silly. It should be 36 minus h squared, because you can see, what have you done here? You subtract. Well, this will make us look at it a little more carefully. What you do is you subtract h squared from both sides of this equation to get your answer. R squared plus h squared equals 6 squared. Well, 6 times 6 is 36. We subtract h squared, and that's r squared in terms of h squared. All done, r in terms of h. Now, all you do, determine the value of h for which the cylinder has a maximum volume. So what we want to do is take that r squared and replace it with the new thing we know in terms of h. It's 36 minus h squared. Well, now we can multiply it out. Pi times h is pi h, times 36 gives me 36 pi h. Pi h times h squared, well, h times h squared is h cubed, so it's minus pi h cubed if you multiply this out properly. Now we need to find the derivative in order to find a maximum. So we use the derivative with respect to h. We go 1 times 36 pi, you get 36 pi. 3 times pi, and then you subtract 1. There's the derivative. And if we're finding a maximum or minimum, we make the derivative equal 0. It's the turning point of this function. Okay, now we just have to solve it. We add 3 pi h squared to both sides. If you divide both sides by 3 pi, 36 divided by 3 is 12. And pi divided by itself is just 1. So it would cancel there, you'd get 12. Square root both sides, and you've got yourself the height that will give the maximum volume to this cylinder, 3.46 centimeters. And that's it. That's your answer. There you go.